Okay, let's step through a sample calculation here for homework number one, which is about assessing running economy. So we have an equation here for computing the rate of metabolic energy expenditure from the measured rate of oxygen consumption, VO2, the measured rate of carbon dioxide production, VCO2, and an assumption on the fraction of the energy that comes from protein as a fuel. These top two things here, VO2 and VCO2, we can measure those pretty easily. Protein, the fraction of energy from protein down here, we can't measure that very easily, but it's not the outcome that you get here for energy is not terribly sensitive to the value that you assume there, fortunately. So we can make measurements of VO2 and VCO2 and an assumption about protein, and from that calculator estimate the rate of metabolic energy expenditure. Now, thing to keep in mind here as you're going through this homework is with the way that we've defined running economy here as the rate of energy expenditure or the rate of oxygen consumption needed to run at a particular speed. For better economy in either one of those variables, you're going to want a lower value of that variable. Okay, so I'll say that again. In this case, if you're going to pick, which of these athletes has the best economy, best by this definition of running economy would be the one that has the lowest value for their estimated metabolic rate, or if you're doing it on the basis of oxygen consumption, the lowest value for their measured rate of oxygen consumption. Okay, so keep that in mind. That can often throw people for a loop and can sometimes confuse students when you read different studies. Sometimes they define the index of running economy as higher is better. Other times they define the index of economy as lower is better. And so when you're talking about running economy in general, you don't really want to think about it as, oh, high is good or low is good, or higher is better, lower is better. It depends on how the index or how the metric of economy is defined in terms of whether better means it's a higher value or a lower value. Here in this homework, the way that we're defining running economy, lower values are better. Lower means that the runner is more economical. Okay, so you have your data here for your three runners. You got their speed and their mass and their protein fraction, CO2 and VO2. So let's take those and plug them into a spreadsheet here and try to get it so that I can see these all at the same time. A little bit smaller. Okay, so I've got my runner, got their VO2, their VCO2, protein, their mass, let's call it M. And here I'm going to calculate E dot, their rate of energy expenditure. So here's my runner number one, number two, number three. My headings bold there. And let's copy over my data there. So VO2 for runner number one was 45.7, 49, 44. VCO2 for that runner is 40.7, 41.1, 32.1. And protein we're going to assume is 0.25 for everybody. And then the body mass is there. Okay. And then to calculate my rate of energy expenditure, I would enter this equation here in my cell there for calculating runner number one's rate of metabolic energy expenditure. So that would be 0.1093 times their VO2 plus 0.2739 times their VCO2 divided by 1 plus 1.12 times P. Okay. And that gets me my E dot for that person. If you stick with these numbers that I have here and don't try to mess around with the units or converting anything, your metabolic rate that you calculate here will have rate or units of watts per kg, or the rate of metabolic energy expenditure in watts per kilogram of body mass. Okay? And then you could copy that down for these other two subjects here. Other thing it asks you to calculate here is the respiratory exchange ratio, which we call it RER. And that's my ratio of VCO2 to VO2. And like the homework says, this is typically considered in exercise physiology an index of the intensity of the exercise. So it's not quite the same thing as lactate threshold. It's not really giving you a sense necessarily for how close you are to the lactate threshold. But the higher your RER is, generally the more intense the exercise is. Okay? And so this is one of the variables that the homework will ask you to take a look at to try to explain the results that you see. Like which runner was, even though they were all going at the same speed, maybe that speed was a little more intense or a little more difficult for some of the runners versus some of the other runners. Okay. And then last but not least here, it asks you to calculate E dot just in watts. And that we just simply take our E dot, that is watts per kg, multiply it by those kgs, and then you get the rate of energy expenditure there just in watts. Okay. So repeat those calculations for each one of these three runners here. For everyone, get a metabolic rate in watts per kg, a respiratory exchange ratio, and a metabolic rate just in watts. And the homework is going to ask you to choose different indices of running economy and which runner is the most economical runner in those indices. Is it always the same one, or is it sometimes a different runner based on the index of economy that you pick? And if you get different results for picking different indices, why? Was there an explanation for why you got a different person defined as more economical depending on how you define the index of running economy? And to explain why you might get a different result depending on how you define the index, that's when you go to RER here, and that might help you explain, oh, well, for this person, even though they had a low E dot, maybe their VO2 was pretty high, and that could be because their RER here was high, for example, because they were doing an intense bout of exercise for that particular person.